Today we're going to look at length and midpoint of a line segment. So the learning goals for today is to be able to determine the length of a line segment and also to determine the midpoint of a line segment. So in order to do this, to determine the length and midpoint of a line segment, the length can be found using this formula here. This formula that says that if we take the x values from both our 2 points on the ends of the line segment, subtract them away from each other, so it's essentially the run, and take the rise, which is the difference between the y values, and square them, and then add them together and square root the whole thing. Now the reason for that is because if we have a look here on our diagram, this is our run, here this is our rise. So if we look here, we've made a right angle triangle, and if we want to try and find the length of our line here, the length of the line segment, then we've got a convenient Pythagorean relationship where we have d squared is equal to the run squared plus the rise squared. So d is then going to be the square root of the run squared plus the rise squared. And the run is x1 minus x2, and the rise is y1 minus y2. So we get, we can see here why we get the formula we do for the distance between 2 points of a line segment, or the length of a line segment. So even if you forget that formula in an exam or something like that, you can always draw a triangle and work it out by using Pythagoras' theorem. The midpoint of a line segment is given by this formula here, and essentially what we're doing is we're finding the mean of each of the coordinates. So we're adding the coordinates up for the x values, so adding x1 and x2 together, and dividing by 2, finding the mean of those two coordinates there. For the y component, we're finding the mean of the y values. And so this is going to give the midpoint on the x, in the x direction, the midpoint in the y direction, and that'll give our precise midpoint of the line. So let's look at our first example here, finding the length and midpoint of a line segment joining these 2 points. Let's find the length first, write down our formula, always write down the formula. Square root of x1 minus x2 squared plus y1 minus y2 squared. Square root of the whole thing there. So substitute our values in. x1 is -3. x2 is 2 squared plus y1, which is -5, minus 8 squared, and we get -5 all squared plus -13 all squared, which is going to be 25 plus 169, which is going to be square root of 194, which is about 13.93. So that's the distance or the length of our line segment, the distance between those 2 points. To find the midpoint now, we use the midpoint formula. The midpoint formula for x1 plus x2, divided by 2, and y1 plus y2 divided by 2. So our x1 is -3, x2 is 2, divided by 2. y1 is -5 plus y2 is 8, divided by 2. And then we get, that's going to be -1 over 2. And here we're going to get 3 over 2. So that's our midpoint we found there. You could answer them as decimals if you wanted to, -0.5 and 1.5 being the y coordinate, if you would like. This problem is quite challenging. Now, finding the values of a, if the distance between 2a and 4, 9 is √5. So first thing we need to do, it says the distance between those two things. So we need to write down the distance formula. D equals square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so substitute known values in. I know the distance is root 5. I know that x1 is 2 and y1 is 4 squared. I know that y1 is a, that's what we're trying to find, and I know that y2 is 9 squared. So then I need to simplify as much as I possibly can. I get here that this is negative 2 squared. This is going to be a minus 9 squared. Continue simplifying and I get square root of 4 plus a minus 9 all squared. Now because this is square root of 5, I can square both sides and I get that 5 is equal to 4 plus a minus 9 all squared. I can subtract 4 from both sides and I get 1 is equal to a minus 9 squared. Now I can take the square root of both sides, but the thing is, if I take the square root of both sides, a minus 9 squared, if I get a minus 9 being a positive number and then square it, I can get 1, but a minus 9 could also be a negative number, and then squaring that would also get a positive number, a positive 1. So I need to show that I get, if I take the square root of both sides, I get plus or minus the square root of 1 is equal to a minus 9. So I've taken the square root of both sides, but it needs to be plus or minus because it could be positive or it could be negative. So now in solving this, the square root of 1 is just 1. So I've got plus or minus 1 is equal to a minus 9. I can look at both cases. I can look at when the 1 is negative and when the 1 is positive. Let's have a look at when it's positive. So I'll split it in two here. Let's look at when 1 is positive. So we can go 1 is equal to a minus 9. Now I can solve this by adding 9 to both sides. I get a equals 10. Might just make this a little bit smaller here. I can also have the 1 being negative. So negative 1 equals a minus 9. And then if I add 9 to both sides, I get that a is equal to 8. So a is equal to 8 or 10. It's equal to two values. Now how is this possible, do you think? How is this possible? Well, if we have, and have a look at the graph here of our value, we know 4.9 is 1 point on our graph. 4.9 is 1 point on our graph. We know the distance is root 5 between our 2 points. We also know that of our first point here, the first point, the x-coordinate is 2. So the x-coordinate has to be somewhere along here. So if I had a piece of rope that was root 5 meters in length, I started it at this point here at 0.49 and then I stretched it out so that it could hit the x equals 2 mark here on the graph. There would be 2 points where it would hit. It would hit above and it would hit below. And so that's why we get two possible solutions, that a equals 8 or a equals 10. There are two possible solutions here. So, and that's the reason why, because we can hit with that same length of rope, we'd be able to hit once on that line and once on the line again at the same kind of equal distance point below it. So just to recap what we've completed this lesson, the learning goals for this lesson, we've looked at being able to determine the midpoint of a line segment and also being able to determine the length of a line segment.